Welcome to Introduction to Aerodynamic Objects Tutorial 9, Aircraft Design. And in this we're going to build and fly a novel aircraft configuration like you can see here in the style of a scrap heap challenge. So our objectives are to reconfigure our conventional aircraft as a canard configuration. Then we're going to verify our control setup using a simulated wind tunnel test, and then we're going to verify free flight performance. So here we are in Unity, and we're at the end of tutorial 8. This is where we left it, and what I've done here is saved it as tutorial 9, and let's get started turning this plane into something new. So what we're going to do is start off on our aircraft, and as usual we're going to change our aircraft manager script. So let's get rid of that one, remove component, and what we want to do is add aircraft manager tutorial 9. So we have our usual busy work of wiring everything up. I guess this is good practice. So let's drag everything in, center of mass marker, propeller, to the transforms. Now we've got the aero objects, so we've got wing, port wing, aero objects, starboard wing, aero object, horizontal stabilizer. And then when we get to the vertical stabilizers, we're going to change this aircraft to have 2 fins. So let's just leave those unfilled at the moment. And then our gains, well, let's start with what we ended up with last time. So we had 0.2, 0.2, and then we had minus 0.5, I think it was on that. Control responsiveness 2, and maximum RPM 100. And we'll go back and adjust these in a bit, but these are good to get us started. Okay, that's the aircraft roughly set up with the aircraft manager script. Let's get on and change the aircraft into something else. So this is the beauty of doing things with aerodynamic objects. You can very easily change things. So let's do the wings first. So if you can, work at the top level of the scene hierarchy here. If you start grabbing things actually in the scene window, you might drag part of the wing. If you select the top level object wing there, you know you're moving the whole thing. So I'm going to grab the Z arrow and move it back, and I'm going to move the wing back almost to the back of the fuselage. Okay, let's move the pilot back, so he's sitting on the wing. Move him down a little bit. And let's move the center of mass back. We're going to change this in a bit when we fly, so somewhere there is good for starters. Okay, let's move the horizontal stabilizer to the front. Once again, dragging the Z axis there, and let's put the propeller at the back. It doesn't actually matter where the propeller is. We could put it on the front, but it's kind of cool to have it on the back. Let's put it on the back. And fins, we could kind of move those forwards, but let's put the fins on the wingtip because that'll look cool. So we've got the vertical stabilizer. Let's move it to the wingtip. So I'm going to start off with the port side one. Lift it up a little bit, doesn't matter exactly where it goes. Okay, that's good enough for the port, so I'm going to relabel this as port vertical stabilizer, and then I'm going to duplicate it and then rename that other one starboard vertical stabilizer. And to get that in the right place, I'm simply just going to reverse the sign of the X coordinate. Bang, it goes over there. Okay, that's kind of looking sporty. If we eyeball this now, I don't know if your design sense kicks in, but if you look at that tailplane or foreplane at the front, it's angled down, so as soon as this thing starts moving there's going to be a downforce on the tail, and that to me does not look like it's going to be balanced. So what we're going to do is find the horizontal stabilizer, and if you remember in the previous tutorial we set the geometry to an angle of -5 degrees. Let's just reverse that, so we've got 5 degrees positive inclination on the front. So what that means now is when we're flying forward we're going to have some lift on the front of there, and that's going to balance the lift on the other side of the center of gravity, and hopefully that will make our aircraft balance in flight. Okay, what else do we need to do? So looking at this right now, if we let it go, the wheels are there, it's just going to fall down. So we need a, we need another set of gear. So we could move these around and create a single nose gear, but just because we're lazy, we're just going to duplicate the existing gear. Duplicate it, and then move it back. So it's just behind center of gravity, kind of in line with the leading edge. It'll do nicely. This is all a bit sort of hit and miss, but if you get it about right, it'll probably work. Okay, other potential problem here, we've got our propeller, and if we rotate that round a bit, it's scraping along the ground, so that's no good. So what we need to do is make our undercarriage a little bit longer. So let's get our undercarriage, select both of those, let's just make it a bit longer, and then drag the aircraft up. Yeah, just got clearance there. The error object is hitting the ground, but remember that's a virtual thing that determines the aerodynamics. The collider is on the geometry that you can see, so as long as that's clear, we're good. Okay, so we've got ourselves a kind of cool looking plane. It's not breaking any of the laws of aerodynamics. We've got a wing, we're using this one in the foreplane at the front to balance it. Hopefully it's going to be stable. If the center of lift is behind the center of gravity, then it's going to be stable. But what we're going to do, like good aerospace engineers, is stick it on our test gimbal in the wind tunnel before we try and fly it, so we can diagnose any problems before we get to flight. So what we need is our wind that we created earlier, and depending on where you've left that and how it's set up, it should be as it was in the previous tutorial, so it should be good to go. But we've got a fluid zone and we've got our wind field arrows all linked up. But at the moment the wind field is over there, so let's just drag it back to the start of the runway and dragging the wind field back there, and then we want to put the plane in the middle of that, so we want the plane 5 meters above the ground, and that's okay. So the plane's going to be moving around, but it's going to be rotating around the center of gravity, so it's going to stay within our wind field. And we set up the wind field 5. Let's give it a bit more wind for this. Let's give it 10 meters a second. Got turbulence turned off, that's fine. Flow field arrows, since the wind is going a bit stronger, I'm going to make the arrows a bit smaller so don't get in the way. And wind speed scale, I'm going to put that as 0.2. Leave everything else the same. Okay, what else we need to do? Let's fix it in space to start off with. So that's not going anywhere. Okay, and one last job which I forgot to do. We have got our aircraft and we need to now connect up the error objects of our fins so that the fins work properly. So we find our fins. So we've got the port and the starboard objects, and we need to drag those across. So we want the port one first, drag that in, and the starboard one second. So what we did before was sent the yaw command to one of the fins. What we've got now in the code is we're sending the same yaw command to both the fins, so both these fins are being cambered in exactly the same way. And if you look on here, the moment arm of the fins is quite a lot less than it is before from the moment arm from the centre of gravity. So whilst we've got two fins, it's fairly close to the centre of gravity, so hopefully it'll be about the same as what we had before. Okay, let's turn the wind on and see what happens. Okay, so it's fixed in space, so we shouldn't expect anything to change, to move, but we can try our controls out. So I'm pulling back on the stick and we're getting a downforce on the front there. So there's something not right with that. So if I'm pulling back on the stick, I want the plane to go up, but actually what's going to happen, it's going to nose into the ground. And if I push the stick forwards, it actually increases the lift on the front. So what that means is that our control is the wrong way around. And we might expect that because when the control surface was on the back, we'd expect it to work differently when we've moved it to the other side of the centre of gravity. So let's fix that straight away. So we go to aircraft and our pitch control gain is the wrong sign. So make that a minus. Let's just check out our other ones whilst we're here. So these shouldn't have changed. So if we do a roll control, so that's me rolling left. So the starboard wing is going up, that's right. And if I want to roll to the right, we've got more lift on the port wing, lifting that up, and that's turning, that's fine. And then rudder, so if I want to go turn left, so what we've got there is a force pulling the back of the aircraft to the right, so the nose is going to go to the left, that's right, and the same if I do it on the other side. And throttle is working the same. So our propeller, whilst we've moved it from the front to the back, it's still blowing air backwards, so we don't have to do anything to our propeller. It's still going to give us some thrust. Okay, that's good. So next step in the wind tunnel testing program, what we're going to do is release the aircraft in the x-axis. So red is x, so we're going to release x, and this is going to enable us to evaluate the pitch stability. Okay, that looks okay. Without doing anything, it's kind of pitched up quite a lot. So what that's telling me is that we need to put some down trim on the elevator, or we'd have to move the center of gravity around. But that's at least that's stable. So if we grab the center of gravity, so if you click on the center of gravity marker, what we can now do is actually move it just by dragging this. So once again, the brilliance of Unity and aerodynamic objects, we can move things around whilst flying. So we're moving the center of gravity around, and what you can see here is actually as we move the center of gravity further and further forwards, this thing is becoming more and more like an arrow where it's just pointing into the wind, which is fine, which makes it really stable. But probably in this configuration we'd never be able to get it off the ground. It's so stable we wouldn't get enough moment from this foreplane to lift it up. So again, too much stability is not a good thing because you just can't control the aircraft. And alternatively, we move the center of gravity back, and as it gets more twitchy, and then eventually the thing goes unstable, so now it's actually flying backwards into the wind. So our aircraft would have completely departed controlled flight before we got there. So we know that somewhere around here, so that is just stable, it's just coming back. Bring it forward a bit more. Okay, that looks like a reasonably happy place. Depending on where you put the wings and everything else, what you want is this thing to kind of balance at a positive angle of attack. So we know it's stable, and given that setting on the foreplane, that seems about right because we've got balance of lift on the wings on the foreplane. So this thing's balanced, so it's trimmed and it's flying at a sort of positive angle of attack. And remember that stability is nothing to do with about angle relative to gravity, it's stability with respect to angle of attack. So the way to investigate that is if we go back to our fluid zone, if we change the elevation angle of the wind, so the wing's coming down, if you notice now, nothing to do with gravity, the plane is at the same angle relative to the wind. If we move the wind the other way, this thing pitches up. So that aircraft, reasonably stable, it's pointing into the wind. And bear in mind, if we got our centre of gravity marker and we moved it right forwards, we could make the plane really stable, but we wouldn't be able to control it. Let's just do that again. So if you notice that it moves much faster going directly into the wind, so very stable. That's good if you've got an arrow. It's not good if you've got a plane because you want a bit more finesse on your control. Okay, that's good. Let's unleash the other degrees of freedom. So let's do roll next. I'll turn off that one, so we're just looking at roll. So roll input, that's good. We can roll backwards and forwards. It's not terribly sporty, but that's kind of good enough for our purposes. And whilst we're here, we can do this dynamically. Let's shut off that and just give ourselves yaw. So now if I put a yaw input in, so if keys don't work, click back into the game view and it'll start working again. There we go, yawing left, yawing right, yawing left. Power on. Okay, we're good. Let's unlock all the degrees of freedom. So now this is freely floating on the gimbal, so we can sort of we can try flying it. So doing rolling left, pitch up, pitch down, yawing left and right. And if we want to, we can turn the turbulence on. Let's reduce the magnitude down a bit. So it's kind of bobbling around a little bit. But that's stable. I'm not doing anything there. The plane is flying its way through the turbulence, so it's got natural stability and it's carrying on flying through the turbulence. Great, I think we're ready for flying. So what do we need to do? We need to unlock the aircraft completely. And let's put it on the ground. And let's turn our wind field off for now. It's always good to flight test in calm conditions. And our cameras are set up as before, so let's give this a go. I'm going to switch to ground camera, so that's F1, so we have a view from down the runway. So Aeroman's waving off his brother. His brother's a little bit more nervous this time because it's a completely new configuration. It's been tested in the wind tunnel, but it's not been tested in flight. But because we've done a good job in setting it up, there's a good chance this is going to fly. Okay, so let's power up. Getting down the runway, getting some speed up, and there we go. Taken off. So I'm not having to do very much. It's flying nicely on its own. So that's me not doing anything, it's just flying around nicely. So a bit of pitch input. I can roll it. Come in and do a circuit. Switch to the orbit view. Looks like he's going to try and do a loop whilst I wasn't touching the keyboard. But there we go. So there's nothing unstable or anything intrinsically unstable about a canard aircraft. If you set it up right, it behaves just like any other aircraft. See if I can bring it in for a landing. Okay, not a very good landing, but there we are, back on the ground. Okay, let's have some fun. How about we turn on the wind field, but put it halfway down the runway, so we fly into it. So we can see what happens when you're flying in still air and then you fly into a box of wind. So let's turn that on. And let's just drag the wind field up the runway a little bit. Okay, see what happens. Okay, we can just see a few little wind arrows there, so the pilot might be looking a bit nervously down the runway, seeing the other strange pocket of wind there. But let's give it a go. So throttling up. Okay, so we got kind of almost a boosted takeoff there, and we're out the other side. Okay, that was fun. So what we got there is just a little bit of super turbulence that the aircraft had to fly through. So we can come back through it again. Whoa. Okay, there we go. We're back on the ground just about in one piece. Not the best landing, but any landing you can walk away from is a good landing. Brilliant. So that pretty much brings us to the end of our tutorial series. So we've come a long way. We started with just some wind, and then we made some blocks that you could put drag on. Then we made a thin block which was a wing that you could get lift on. Then we started putting things together and made a weather vane, so a basic stable aerodynamic object that points into the wind. Then we added a wing to that and looked at how you change the centre of gravity and how that affects the stability. And then we made a glider and we used some vertical wind to keep it up. And then we made a propeller and we used the propeller to keep the aircraft up. And then we put some flight controls on the aircraft, and then finally in this episode we've done our scrap heap challenge, moved everything around and built a completely new aircraft from the parts. By applying some basic aerospace engineering principles, we've managed to make something that flies perfectly well as a custom aircraft. Great, well I hope you've enjoyed going through these tutorials, had as much fun watching them as I had making them. It's certainly been a bit of a journey finding out what you can do with the tool, and really this is just the beginning. There's so many things that you can make, and I invite you to go and have a look at some of the other web demos that you can see of other things you can build. So you can build things like a biplane or a airship or hang glider. You can pretty much make anything in terms of things that fly, and that's the beginning in terms of aerospace sort of flight vehicles. But then there's whole other worlds which we're starting to developing, things like boats with sails on, and then there's the world of animal aerodynamics, of birds that flap their wings and insects that flap their wings. So those are all things we've got in the pipeline, so hopefully there'll be some tutorials on that coming up soon.